Hi guys, this is AS Chemistry, moles and molar ratio. Question 9. The reaction between aluminum powder and anhydrous barium nitrate is used as the propellant in some fireworks. The reaction produces the metal oxides and nitrogen, and this equation is given. Which mass of barium oxide is produced when 5.40 grams of aluminum powder reacts with an excess of anhydrous barium nitrate? So, from the given equation, the parts that we need are 10 moles of aluminum reacting with barium nitrate to produce 3 moles of barium oxide. So, for aluminum, the AR is 27, and for barium oxide, the MR would be AR of barium plus AR of oxygen, giving us a value of 153.3. So the total mass of aluminum used would be 10 into 27, which would be 270 grams. And the total mass of barium oxide used would be 153.3 into 3, which would give us 459.9 grams. So this is what the reaction actually has in masses. 270 grams of aluminum produces 459.9 grams of barium oxide upon reaction with an excess of barium nitrate. So the question asks, how much barium oxide would be produced if 5.40 grams of aluminum are used? So the calculation here would be 5.40 divided by 270 multiplied by 459.9, giving us a value of 9.19 grams of barium oxide, which makes option C the correct option for this question. Question 10. Ammonium sulfate in the soil is slowly oxidized by air, producing sulfuric acid, nitric acid, and water as the only products. How many moles of oxygen gas are needed for the complete oxidation of 1 mole of ammonium sulfate? So the formula of ammonium sulfate is NH4 twice SO4. This would react with oxygen, the moles of which needs to be calculated to produce. Now this produces sulfuric acid, H2SO4. It produces nitric acid, HNO3, and it produces water, H2O. Okay, so if we have 1 mole of ammonium sulfate as stated in the question, so we would need 4 nitrogen atoms to be present on the product side. So which makes the moles of HNO3, in fact 2 moles, not 4 moles, it's NH4 twice. So we need 2 moles of nitrogen atoms on the right. So 2 moles of HNO3 would be present. 1 mole of sulfuric acid would be present because there is only one sulfate present on the reactant side. And now in order to balance the hydrogen, so on the reactant side, we've got 4 to the 8 hydrogen. On the product side, we have 2 in sulfuric acid, 2 in nitric acid, and 2 in water. So 2 are remaining. So in order to balance those two, we need to multiply water by 2. So this makes 8 hydrogen atoms on the right. So now since we have balanced sulfur, nitrogen, and hydrogen, the only thing remaining is oxygen. So the total oxygen present on the product side are 4 atoms in H2SO4, 3 to the 6 atoms in HNO3, making the total 10, and 2 atoms in water, making the total 12. Out of those 12, 4 are already present in sulfate of ammonium sulfate. So 12 minus 4 is 8. We need 8 atoms of oxygen. So 8 atoms of oxygen means we need 4 molecules of oxygen. So here we end up with a molar ratio of 4 for oxygen, making option D the correct option for this question. Question 11. In China, the concentration of blood glucose C6H12O6 is measured in millimoles per liter. In Pakistan, the concentration of blood glucose is measured in milligrams per deciliter. The unit liter is equal to 1 dm cube and the unit deciliter is equal to zero point 0.1 dm cube, which means deciliter is 1/10 of a liter. 1/10 of a liter is a deciliter. Okay. A blood glucose concentration of 18.5 millimole per liter indicates a health problem. What is 18.5 millimole per liter converted to milligram per deciliter? So, moles to mass, N is equal to M upon MR. We need to convert moles to mass. So, mass would be equal to moles into MR. For this, we need the MR of C6H12O6. So 12 into 6 for carbon plus 12 for hydrogen and 16 into 6 for oxygen gives us an MR value of 180. So number of moles is 18.5 millimoles into 180 gives us a value of 3330. So if millimoles are being converted into mass, so the mass that we obtained would be in milligrams. But this was in liter. So milligram per liter. So 3330 milligram per liter. Now we need to convert it into deciliter. And a deciliter is 1/10 of a liter. So 3330 into 1 over 10. 1/10 of this will give us a value of 333 milligram per deciliter. So this makes option C the correct option for this question. Question 12. People are advised to eat less than 6 grams of salt sodium chloride per day for health reasons. Which mass of sodium is present in 6 grams of sodium chloride? So, according to the equation, Na plus half Cl2 produces NaCl. So, the AR of sodium is 23 and the MR of sodium chloride is 58.5, which is 23 plus 35.5. So, the question asks, what mass of sodium is present in 6 grams of sodium chloride. So what mass would be present in 6 grams of NaCl? So this would calculate to 6 divided by 58.5 multiplied by 23, giving us a mass value of 2.36 grams of sodium, making option B the correct option for this question. Question 13. Aspirin C9H8O4 has an MR of 180, can be made by reaction between 2-hydroxybenzoic acid C7H6O3 having an MR of 138 and ethanoic anhydride C4H6O3 having an MR of 102. The balance equation for the reaction is shown. So let's put down the MR values over the given compound. So for aspirin, it is 180. For 2-hydroxybenzoic acid, it is 138, and for ethanoic anhydride, it is 102. Okay. If a reaction mixture consists of 10 grams of each of the two reactants, what is the maximum mass of aspirin that can be produced? So, looking at the MR values, we can see that if we use 10 grams of each of the reactants, so the mass of the first reactant is 138 and the mass of the second reactant is 102. So if 10 grams are completely used up for the first reactant, so the mass used for the second reactant would be less than 10, which we don't know right now. So we are not going to consider the second reactant, we are going to consider the first reactant because it will be completely used up. And we need to find out how much of aspirin does this produce? So these are the values we're going to use. So the calculation would be 10 upon 138 multiplied by 180. This gives us a mass value of 13.04 grams of aspirin, making option C the correct option for this question. Question 14. Strontium metal can be extracted from strontium oxide by reduction with aluminum. One of the possible reactions is shown. What is the maximum mass of strontium metal that can be produced from the reduction of 100 grams of strontium oxide using this reaction? So, the MR of strontium oxide would be 87.6 plus 16, giving us 103.6 grams. The AR of strontium is 87.6. So 6 moles of SRO produces 3 moles of SR. So multiplying 103.6 into 6 gives us a value of 621.6, and multiplying 3 into 87.6 gives us a value of 262.8. So the amount that the question asks us is 100 grams of SRO would produce how much strontium metal? So the calculation would be 100 divided by 621.6 multiplied by 262.8, giving us a mass value of 42.28 grams, making option B the correct option for this question.